Okay, this is the last video from section 6.2 on solving triangles, and then this is just one more application we can get from this geometric idea that we have. And the idea is, well, all of you know how to find the area of a triangle. And if I tell you I have a right triangle and this is 6 and that's 4, can you find the area? Sure. You all know area is 1/2 base height. So that's 1/2 times the base, which is 6, times the height, which is 4. You get 12 and you're done and you're good and it's easy. But we said one of the reasons we need to know the law of sines is all triangles are not right triangles. Right triangles are really boring and simple. What happens if you have a triangle that isn't a right triangle that isn't boring and simple? So we created a law of sines so we could solve a triangle that wasn't a right triangle. It works for right triangles, but we don't need it. Well, what if we want to find the area of a triangle that isn't a right triangle? Say I have this triangle right here. And this is 14. And this is 30 degrees. And this is 10. Can you find the area of that triangle? Well, let's see. The area formula, we just used it, is 1/2 base height. I know the base, it's 14. I don't actually know the height because you guys know that if you want to use cool speak, it's a slant height. It's not the actual height, the altitude of the triangle, so I can't use that formula. So what can you do? In the first video from this section, we did a little geometric trick. We turned this triangle into 2 right triangles by drawing a perpendicular bisector like that. Well, now, do the exact same thing we did before. If this is the height, call it h. And then before, we said, using our right triangle trig ratios, given that angle, sine of 30 degrees is equal to the opposite, which is h, over the hypotenuse 10. Then I can multiply that out, and I get 10 sine 30 degrees equals h. And now, that's some messed up number. I can get it out of my calculator, but that's actually the h, which I could then plug into this formula. So if I wanted to know the area of that triangle, well, since I found h, I could just say area equals 1/2 base height. So that's 1/2. The base is 14. We knew that. The height, well, I just solved right here. It's 10 sine 30 degrees. And then now I can just solve out. Let's see, 1/2 of 14 is 7. 7 times 10 is 70. Sine of 30 degrees, unit circle, all of you know the unit circle. Sine of 30 degrees is 1/2. And then 70 times 1/2 is 35. And there we go. This is one trick you can do. You can just algebraically find the height of the triangle and then solve it all out. Your book gives a formula for this. You don't necessarily need to memorize it if you understand how to solve it on your own. But if you don't want to go to the trouble to algebraically solve this out like I just did, you have to memorize the formula. And essentially the way the formula works, do literally the exact same thing, but now, instead of giving these numbers, I'm just going to call them letters. And we'll say this is angle A, so that's side A. This is angle B, so that's side B. This is angle C up here that I cut in half, so that's side C down there. And now let's see. Don't get the different letters confused. This is A for area, that's A for an angle. Don't get them confused. This is B for the base, not side B. It's the letters your book uses, so we kind of have to go with it. But if I want to find the area of that triangle, it's 1/2 base height. The base of my triangle is C. I know that. I just need to find the height. Well, that's h. Algebraically find it. Using my trig, sine A equals h over b. And now multiply the b. H equals b sine A. Now plug those into that formula. And again, don't get your letters confused. I know they can be a little confusing. The area is 1/2 the base times the height. So that's 1/2, my base is lowercase c. My height, h, is b sine a. And now that's a formula for my area. Essentially, the idea is, if you don't want to do all the algebra out like we did and kind of create an altitude and then find your sine and do all that algebra, all the formula says is, to find the area of a triangle, you need an angle, call it A, and then you need the two sides, it's the two sides and the included angle, or it's the two sides that form an angle. If you have that angle A, and you know the lengths of the two sides that form that angle, B and C, then you can find the area of the triangle. So as an example, suppose I have this triangle right here. And we'll say this is 8, this is 5, and that's 40, we'll be nice and say 45 degrees. If I could draw 5 correctly. There we go. I want to find the area of that triangle. We know if I wanted to, I could draw a perpendicular bisector, and then I could do all that other stuff. I would encourage you to do that on your own, just to check this once the video is done, to make sure it works. But if you don't want to do all of that, I have an angle, and I have the two sides that form that angle, or if in other speak, I have the two sides in the included angle. So I can just plug it into the formula. Area equals 1/2 C times B, or B times C if you want to be alphabetical, product of those two sides. 8 times 5 times sine of the angle, 45 degrees. And that's just 8 times 5 is 40, half of 40 is 20, 20 sine 45. You all know sine 45 is root 2 over 2. 2 will cancel with the 20 and leave a 10, and you get 10 root 2. Or just throw it into your calculator and get like 14.142, etc. But again, this is the formula your book gives. It actually gives 3 different formulas based on whether you want to have it in terms of angle A, angle B, or angle C. It doesn't matter. The principle is always the same. If you know 2 side lengths and the angle between them, you can find the area of the triangle. You can also always find it doing the algebraic trick that we did. So if you don't want to memorize the formula, you just have to understand how to draw this perpendicular bisector and then find it algebraically on your own. Either one works. I don't really care which one you use. That should be it for this. And like I said, if you want to test this, find this perpendicular bisector, find the actual height, use your trig ratios, solve it all out, and see if you actually get the same thing. You should. The last thing I'll mention really briefly, this only works, like I said, if you have the scenario, you have 2 sides and the included angle. If I had a triangle where, say, this was 6, this was 4, and that was 37 degrees, I can't use that formula then, because this angle is not the included angle for 6 and 4. This angle would be. In order to use this formula, I would have to somehow get that angle. So just because you know 2 sides and an angle doesn't mean this formula works. It only works under a certain condition.